Hello everyone, today we're going to be talking about the Pythagorean Theorem, and two things to know right off the jump here is that we're going to be working with right triangles. And if you haven't seen my video in the past I made about triangles, all that means is that a right triangle contains a 90-degree angle, and you'll typically see that in the bottom left, but the triangle can be positioned however, and that you will also know two side lengths. That might seem like a confusing thing to think about if you haven't seen the Pythagorean theorem before. However, it'll make more sense as we talk about it. So, when it comes to Pythagorean theorem, we have a right triangle, and we can look at three side lengths. And we'll call those side lengths A, B, and C. These are just variables that we're putting in place of actual side lengths. Don't really mean anything, but it's just kind of how we recognize these sides in this example. So, the equation is A squared plus b squared equals c squared. So if you can remember that, you pretty much got it down, especially if you have a little practice with your algebra. So all that means is that the side squared of a plus the side squared of b equals the side squared of c. And this will make more sense as we get into some examples of it. So let's look at some examples here. Say we have a triangle and we know this side length is 3. And we'll say this one is 7. What we don't know is the side length of the hypotenuse in this case, which the hypotenuse of a triangle is the longest side. So in order to find that, what we can do is actually apply the Pythagorean theorem. So we have A and B. Now keep in mind we can call either side A or B. It doesn't necessarily matter. But we can call this third side C, because that's what we're trying to find. So what we can do is plug these numbers in. So we know 3 squared plus 7 squared, because that's A and B, equals C squared. And we don't have C's measurement, but that's what we want to find. So let's just work through the math here. 3 squared is 9, plus 7 squared, that's 49, equals C squared. So 9 plus 49 is 58 equals c squared. And now we don't want c squared, we want c because we want the side length c. Just like we start with a and b, but we're squaring those just for the equation, we want to be able to find c, not c squared. So since we have c squared, if you have some practice in algebra, this would make more sense. However, you don't necessarily need it. What you can do is simply take the square root of both sides. So now we can say that side C equals the square root of 58. And you can plug that in your calculator to figure out whatever side measurement that is. However, that's just kind of how the general idea of it works. So you're going to be plugging in these side lengths. You're going to have a third side length that you want to find. And you just work through the algebra according to a squared plus b squared equals c squared, and that will give you a measurement. So let's work through another problem here, just get an idea. But this time, how about we say that we have c? Well, maybe we want to find a. So this definitely won't be up to scale, but I just want to kind of exemplify more of the math here rather than the actual scale of the problem. So let's say that we're looking for a here. We have c and b. So we can write out the whole equation, a squared plus b squared equals c squared. And we want to find a. So we're going to have a squared here. We know that b squared, 7 squared, is 49, equals c squared, 13 squared is 169. Just like that. So now what we can do minus 49 to both sides here. 169 minus 49 is 120. So we brought that out of this side, brought it over to here. And now we know that a squared is equal to 120. We don't want a squared, we want a, because we're talking about side lengths here. So what we can do, we can take the square root of both sides, now we know that a is the square root of 120. So just like that, once you know the equation of a squared plus b squared equals c squared, you can kind of work through it one step at a time. Now I know these aren't the best numbers to work with, so we're just going to use a very common example down here. Just so you guys can see that it does add up actually, and that we can see this in real life examples too. So let's say we have side length 3, 4, then we want the hypotenuse, and just imagine that we got a right angle here. I didn't draw it perfect, but thought it was there. So we know that a squared plus b squared equals c squared. We know that a is 3, so 3 squared, b is 4, 4 squared equals c squared. 3 squared is 9, 4 squared is 16. Then we got c squared on this side. 9 plus 16 is 25. Set that equal to c squared. And now we take the square root of 25. So we can say c equals the square root of 25, which equals 5. So that is one of the more common examples you'll see. We call that a 3, 4, 5 triangle, just because it's got a nice little ring to it, very easy to memorize. However, it just applies all the rules of the Pythagorean theorem that we talked about before. So let's just go over a little bit of a recap on everything. We have a right triangle, and we're going to be given 2 side lengths, or you might be given one and you have to find another one. You can kind of work your way around the triangle. However, you do need 2 of the 3 side lengths to find that third one. And the equation for that is a squared plus b squared equals c squared. Any triangle that is a right triangle can be applied with this formula. As long as you have 2 of the side lengths, you can find a third. You can start with the hypotenuse, have one of the legs, find the other leg, or both legs, and then find the hypotenuse. All you have to do is follow this equation and work your way around it. So if you guys have any questions regarding this, feel free to leave it in the comments. I'll be glad to answer them. Otherwise, I hope to see you in future videos.